This is the video on data basics. We're going to start with just a review of some of the terms that you used in the past. The first one is the mean. To find the mean of a set of data, you're going to add it all up and divide by how many data points there are. So in this case, for this one, you would do 4 plus 2 plus 10 plus 2. And then we're going to divide that whole thing by 4 because there are 4 data numbers. So we'll have 4 plus 2 plus 10 plus 2, which is 18, divided by 4, which gives you 4.5. So the mean of this data here is 4.5. Median. When you have the median, you want to put the numbers in numerical order from least to greatest. So we would have 1, 2, 2, 7, 8, 8, 9. Let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you put them in numerical order from least to greatest, and then you want to find the middle number. So 1 goes with 9, 2 goes with 8, 2 goes with 8, and the number in the middle is 7. So the median for this particular set of data is 7. If there was an even set of data, then you'd find the average of the middle. For example, let's say the 1 didn't exist, and our median was here between 7 and 8, so we would do 7 plus 8 divided by 2, which would be 7.5. So two middle numbers, find their average. Although mode is not technically a measure of central tendency because it doesn't show us where the center of data is, it's often grouped with it. Mode means the number that occurs most often. So if you look down here at the set of numbers that you're given, the numbers 1 and 3 both appear the same amount of times and they occur the most often. If for some reason that you have like a set of numbers that each appears just once, then you would say that there's no mode. So measures of central tendency, mean, and median. Then we can get into variation. With variation, one of the ways you can talk about how the data varies is when you're talking about the range. Remember, the range is going to be the highest number, so in this case 18, minus the lowest number, in this case 1, so the range is going to equal 17. Mean absolute deviation is another way to talk about variation, how much everything deviates away from the mean. So to do this, step number 1, you're going to actually need to find the mean of the data. So in this case, we're going to do 2 plus 5 plus 10 plus 2 plus 1, which is 20, divided by how many data points? 5, which makes the mean 4. And then step number 2, you're going to find the difference between the mean and each data point. And you're actually going to add these together, but specifically their absolute value. So, if you look here, since our mean is 4, we're going to do 4 minus 2, their absolute value, added to our mean of 4 minus 5, added to the absolute value of our mean 4 minus 10, added to the absolute value of 4 minus 2, added to the absolute value of 4 minus 1. And all of that's going to be divided by the number of data there are. So number 3, we're going to divide by number of data. So in this case, we have 1, 2, 3, 4, 5 numbers. So then you're going to just do this all on the calculator. Give me just a second. So the top, I will get 14 divided by the bottom will be 5. So 14 divided by 5 gives me a mean absolute deviation of about 2.8. And then interquartile range is your third quartile minus your first quartile. And we'll get into later on how we actually find those quartiles. But in this case, we've got 20 minus 12, which is 8. So our interquartile range, which also shows us variation, would be 8. You can also talk about some other features within a graph, such as the spread. If you look at these two here, typically when you're talking about the spread, you're comparing less spread and more spread. So for example, this is 8 minus 2, which is about like 6 units apart, versus this would be like 9 minus 1, which would be 8 units apart. It's more spread out, it has a larger range. Symmetry means that you can actually draw a line down the middle and fold it into two equal halves, versus if we did a line down this middle, this would not make two equal halves. So this is not symmetric, this is symmetric. Number of peaks is kind of like a mountain. So this has like one mountain peak versus this has two mountain peaks. When it's got one, we call it unimodal. When it's got two, we call it bimodal. Any amount of peaks after that we don't really name. But then I want to point out this histogram right here. This histogram here is your traditional, what we call a bell curve, because it actually goes up and then comes back down. So this would also be described as bell-shaped. Skewness means that the data is gathered on one side or another. So in this example here, all the data is gathered here on the left. That's where the majority of the data is, so we call it skewed right, and vice versa. Uniformity means that there's the exact same number of data for each item that's represented. So maybe we could say there's like 5 ones here, 5 2s here, 5 3s here, 5 4s. So every one of these data sets has 5 numbers of it represented. Gaps mean that you have clear areas within your data that are missing information or missing points. So here we've got 0 to 3 is represented, and then 6 through 9, but nothing is representing 4 or 5. There was no 4 or 5 within the data. So a gap occurs between two sets. That can be compared to what we call outlier. An outlier is that one extreme number. So here we've got that one extreme number here at 9. And we would not call this a gap. And I want to point out too that if you see something like this, which kind of looks like the same graph, but that 9 was tall, that means we have lots of 9s represented. Therefore, this would not be an outlier. If there's a bunch of them represented, we would say it has a gap. But since there's only just like 1 or 2 of them represented here, then we would call this an outlier.